This video is just a short review of domain and range, finding the domain and range of functions, specifically finding domain and range from the graphs of those functions. Now, you learned all of this in Algebra 1, but for most of y'all that was 2 years and who knows how many alcoholic beverages ago, so I'm just going to go back and recap everything just in case there's something you don't remember. But domain and range, remember domain is all the inputs of a function, the inputs, and the range is all of the outputs. All right, now with functions, usually for the inputs, the domain, we're dealing with one letter specifically. And that's the x value. And on the graph, the x numbers, do they go up and down or left and right? They go left and right. So finding the domain of a function, we're looking at how far left and how far right the graph goes. So the range is the outputs. For the range, we're talking about the y values. I guess I should put an S on that. All right, and then the y's go which direction on a graph? They go up and down, but when we list these, we always list the lowest first, the lowest that it goes, and then the highest. Now, there are multiple ways of writing the domain and range. Okay, you may have seen it like this, written as an inequality. All right, -3 less than x less than or equal to 4. Now, what does that actually mean? It means x, whatever x is between -3 and +4. All right, now, this equal to line, remember, that means it could include 4, but it can't include -3. So this inequality, it's called a compound inequality, can also be written in what's called interval notation. Same thing. This means the same thing as this. It means x is any number between -3 and 4. Now, you notice there is a parentheses right here because it does not include that number. All right, so if you're writing a parentheses, that means it does not include it. Include, I can spell include. And then if it does include it, like here we have an equal to line on the 4, you use a square bracket instead of a curly parentheses. So a square bracket means it does include it. All right, so for example, if it included both numbers, then I'd put a bracket on both ends. Now, this one, y is greater than 9. How could I write that in interval notation? All right, is 9 the smallest that y can be or the biggest? 9 is the smallest, so the lowest it could go, let's say, is 9. Now, it doesn't have an equal to line. It does not include 9, so should I put a bracket or a parentheses? A parentheses. So I say parentheses 9, comma. Now, it's any number bigger than 9. So it keeps going on forever. That means it goes up to infinity. So I put an infinity symbol. And you always use a parentheses with infinity. It never includes infinity. All right, you never actually make it there. Buzz Lightyear never made it. All right, 9 comma infinity. So let's use this to write the domain and range of these functions. Remember, domain is left and right. The x value is how far left and right it goes. The range is how far down and up it goes. Now, we could write it either way, as an inequality or interval notation. The first problem, I'm going to write it both ways. After that, I'm just going to stick with one way. So you're thinking, wait, do I have to write it both ways? No, you don't. All right, but on your test and on the ACT, it could ask you either way. So you have to know what both of them mean. So if you look at graph number 1, all right, this one, by the way, what kind of function is this? Makes a V. It's an absolute value function. So looking at just how far left and right it goes, if I just trace this to the left, all right, would I stop somewhere or would I keep going forever? I'd keep going forever. What about going to the right? Would it stop or would it keep going forever? Forever. So the domain, I would say, furthest left is -infinity because it goes to the negatives, and then to the right, it's going out to positive infinity. Or you can write all real numbers. All right, now the range, we're talking about the y numbers now. The lowest that this graph ever goes, if I trace this right here, this point, what's that y number? It's -3, and it does touch it. So I would put a bracket, -3, comma, and then the highest that it goes, no matter which way I'm going, if I trace this, am I going to stop somewhere or go up forever? I go up forever. So negative 3 to infinity. Or if you're writing it as an inequality, I'd say y is, since negative 3 is the lowest, it goes above negative 3. Would y numbers be greater than or less than negative 3? It'd be greater than or equal to, because it actually touched that. So that would be the range written as an inequality. Let's look at a couple more. Number 2, the domain. If I just put my pen on here and I'm talking about left and right, if I trace it all the way to the left, going this way, would it stop or would it keep going? It'd keep going. What about going to the right? It goes on forever. So my domain is negative infinity to positive infinity. Or you could say all real numbers. Now the range. All right, this time, the range. The lowest that it goes, if I trace this line down, it's going down forever. The highest that it goes up forever. So the range is going to be negative infinity to positive infinity. Usually when it's a linear graph, most of the time, we're going to see some exceptions in a minute, but most of the time, the domain and range can be negative infinity to positive infinity. All right, number 3. The domain this time, if I trace this, I'm looking at left and right. The furthest left that it goes, does it keep going or does it stop? It stops right there. That's negative 3. So the domain, I'd say negative 3, comma, how far does it go to the right? Infinity. Now the range, if I'm going to the lowest point on here, right here, it's got a lowest point. Now be careful. The lowest point is not negative 3. The range is the y numbers. The x number is negative 3 right here. What's the y number at this point? It's 0. So the range, it goes from 0 and then it keeps going up forever. 0 up to infinity. Now why did I put a bracket on 0? It's not touching 0. The y number here is touching this point. This is point 3 comma 0. So it is touching a point that has a y number at 0. All right, most of the time, almost always, when you have a number here, you're going to have a bracket on it. Again, some exceptions we'll see in a minute. But now I want you to try to answer 4, 5, and 6. Pause the video, try to do those, and then unpause it to check. Did you do it? Of course you did. So now number 4, furthest left it goes, it's right here at negative 3. Furthest right it goes is positive 3. I'll just show you right here. So same thing with the range. The furthest down it goes is negative 3. The furthest up it goes is positive 3. So I'd say negative 3 to 3 for both of those, domain and range. For number 5, this parabola, it goes left and right forever. So all real numbers are negative infinity to infinity. The lowest it goes is that point right here. Now we're talking about the y numbers. The lowest y point is negative 3, and then it goes up forever to infinity. Number 6, kind of sideways absolute value, the domain, the furthest left it goes right here, this x number is at negative 3. It goes to the right forever, to infinity. The range, down and up, this isn't the lowest point. All right, if I'm tracing this down, right here, the tip of the arrow is the lowest point. It's going to keep going down. So down to negative infinity, and it goes up to positive infinity. Now, couple more, if you flip over to the back, couple more I want to look at together. I'm going to save the rest of these for y'all to do, but I want to look at number 8 and number 11 together. Number 8, all right, the domain, if you're looking at furthest left it goes, it's right here, this open circle. If you recall from Algebra 1, when you were graphing inequalities, all right, graphing inequalities, sometimes you had x is like greater than or equal to 5, and then you had to like put a closed dot and shade to the right of it, and sometimes you had to graph just x is greater than 5, and you had an open dot, shade to the right. What did that open dot mean? Open dot means it does not include that point. All right, it's everything up to that point. Closed dot means it actually includes that point. So number 18, that open dot, it's at negative 3, but it never actually touches it. So the domain, this is an example where I'd have to use a parentheses with the number. Parentheses, negative 3, then it goes to the right to infinity. And then the range, be careful, the lowest that it goes down here, and then it goes horizontal. So any of these points right here, the lowest that it goes, what's that y number? It's negative 2. I know it's kind of hard to see. This is the x-axis right here. There's negative 2, and it actually includes that point. So bracket, negative 2, comma. Now the highest that it goes, all these points right here, the y number is what number? Positive 2. One other one, looking at number 11. domain. This is a vertical line, straight up and down. So domain, no matter where I am on this line, the furthest left it goes is what number? -2. What's the furthest right it goes? -2. So I don't have to say -2 to -2. When it's just one number like that, you could just list the number. The domain is just -2. Now the range, what do you think the range is? It's -infinity to infinity. It goes down forever and up forever.
I have a navy blue.
So now I want you to pause the video, answer the other 4 really quick. Did you do it? Sure you did. Let's check. All right, number 7, left to -4, right to +4. The lowest it goes, either of these points, the y number is 0. The highest it goes is 4. We did number 8 already. Number 9 goes left and right forever, -infinity to infinity. The range, it goes down forever to -infinity. The highest it goes, this y number right here, you're not looking at the x number now, you're looking at the y number, is +3. Number 10, it's kind of hard to tell, but that is a closed dot right there. All right, so the furthest left it goes is that -4, and you'd put a bracket on it. It goes to the right forever. The lowest that it goes, this vertex right here, the y number is -2. The highest that it goes, if you go on this side, it goes up forever. And then we did number 11, number 12. It goes left and right forever, so all real numbers. And then the range, it never goes above or below the 2, so you could just write the number 2. Ta-da!